Oh goodness, too many links open. Okay, here we go. All right, I'm going to go ahead and get started with the review of the slides. All righty. So, like I kind of went over a bunch of this stuff. But if you have specific questions and you want to ask like in the moment, just unmute and ask. That's totally okay. If you use the raise hand feature, I might not see it. So that might be a better time to go in and pop in to see D stuff. And this this little note here, both of us have little kids that are going to be getting ready for bed around 7:30. So if one of them pops in to say goodnight, consider yourself lucky. That's your good luck charm that you got to see their cute little faces. All right, so everything that's in here is in this folder like I talked about. And yeah, so let's go ahead and let's get started. First of all, these are some links that I have accumulated over the years. This first one is a YouTube playlist of some different videos I found. So I've just kind of been adding them on here. This is the APCSA review playlist. You might not be aware that every AP class has review videos that are created by College Board. So some of them are really good, some of them not so good, but they're available. This document right here, this is a spreadsheet with all of the FRQs, questions and scoring guidelines all the way up through 2019. Thank you, buddy. All the way through 2019. So this could be a great thing to take a look at. And this Chief Reader Report and the Student Performance Q&A, that gives you some insider information into the most common mistakes, areas where students were going wrong. So again, if you've been doing a lot of prep and you're trying to figure out some last minute things you can do to really improve your score, that might be a good place to take a look, especially if you have done these questions and you're familiar with the prompts. Let's see. So this FRQ by topic and where to find them. This is another good document that I've gotten over the years, or website rather. And so like, let's say, for example, you're looking for more practice problems on inheritance or on strings. There's all these different resources of where you can find different problems. Um, Keep in mind there are some topics that have been taken off of the AP subset. For example, interfaces are no longer tested. Um, but if you're looking for practice, this is a great way to find a question without having to just keep on searching and downloading. You might recognize some of these names, like for example, student and seating chart. Pretty sure we did that problem in class. Same thing with this sparse array and diverse array, but I don't think we did gray image. I don't remember if we did crossword puzzle. So sometimes when you see the name of the FRQ question, it might be familiar. Like I know we did climb info. I know we did random letter chooser, but others might not, and that would give you some other questions that you can go and look at. Let's see. So this is that folder I showed you with the practice tests. And then this rapid review, this is something that I scanned from one of the books that I have. And I went through and I essentially like it's like a little summary of every single unit and then with a few extra questions. So this might be again another thing to read over for some last minute prep. Okay, so let's make sure we understand the layout of the test. Two parts, 90 minutes each. So the first 90 minutes, you have 40 multiple choice questions. They're each worth 1 point. And then you have a short break and then 90 minutes for 4 FRQs, each worth 9 points. Now, if we're doing some fast math here, you're going to see that that adds up to be 36. And they just do a scaling to get it up to 40 points. So what does this mean for us? Well, let's talk test strategies. First of all, every MC is worth the same. So if you encounter a problem that either seems really hard or looks like it's going to take a lot of time tracing, skip it, come back to it. Same thing is true for an FRQ. If you read a problem and you're just like, what? Skip it and come back to it. They're all worth the same amount of points. And you don't want to waste time on a problem you could definitely get right trying to understand a problem that you might just have to guess on. So I just want to really stress that. Even problems that involve a lot of code tracing, even if you're most likely going to get them right, it's still better to go ahead and just skip it till the end. So in terms of what to expect, I just want to drive home that the different FRQ problems, they are now broken up, that each question has a set category. It didn't used to be this way. So if you're looking at older AP tests, you might notice that there's a 2D problem on question one. That's how it used to be. In 2019 or 2020, they rearranged things and they decided that this is how the FRQs are always going to be. So just I really want to stress that there are two questions that involve having to know how to work with arrays, array lists, 2D arrays. You have to know that syntax. Like you have to be able to write those loops from memory and also be comfortable with how to write for each loops. And so that's something that we're going to definitely recap today. All right, so what are things that you should memorize? This is always a question people ask because there's so much that we learned, and some of it we look at our notes, some of it we use code completion to finish, some of it you Google, and the question is, what do I have to actually know? So, first of all, you have to be comfortable with your objects on how to what the difference is between declaring and instantiating them. So, the declaring would be like saying, let's say your class was a student class, saying student S1. And then instantiating would be saying S1 equals new student. Now, you can do that all in one line. You can break it up over two lines. But it's important that you understand the difference between those. Another thing that's super important is that all instance data has to be private. Even though there might be some cases in your personal coding where you would make it public, the AP wants private every time. And it's often a full point on your FRQ, which is a silly point to miss. You need to be really comfortable with constructors. So when you're looking at your free response prompt, if it shows you how an object is created, that is telling you the order of your parameters, the number of parameters. And so you want to make sure that you're comfortable with reading that constructor header and knowing how to use that to make your like constructor code. Um, these are the methods that we need to know how to use for the string class. Now, I put here use because you will have these on that quick resp or that Java quick reference sheet that I mentioned at the beginning of the review. So all of these, as long as you know how to use them, you will have a short description and the method header on that quick sheet. The one that students typically mess up the most are substring because they forget what is and is not included. So remember with substring that this ending index is not included. And an easy way to remember the amount of characters your substring is taking is to do, in this case, B minus A. And that tells you how many characters long your substring will be. Another thing to mention is that if let's say we have the word Denna, and Denna has 5 letters. If I were to do the substring 3 comma 5, students often think that that's going to give you an error because they say, oh, well, it's going to go out of bounds. But it's not, because remember, that last index is not inclusive. So if I said 3 comma 5, DENNA, if I look at these indices, that's going to be the last N and the A. Sorry, I guess that's kind of backwards for you guys. So if this is DENNA, it would be these guys because it starts at index 3. So it would take index 3 and index 4. Again, if we thought, substring 3 comma 5, 5 minus 3 is 2. So it'll take 2 characters starting at index 3. All right. Let's see, math.random. So we need to be comfortable with how to use math.random in either one of these scenarios. So understanding that the word exclusive means it excludes or leaves out. So you could think of that like this parenthesis, or inclusive includes or contains. So we'll go over this specifically in a minute, but you need to be comfortable with that. Most likely you'll have a multiple choice question with it. There's also a good chance it might show up in an FRQ. When you're looking at your loops, we want to make sure you feel comfortable with how to start at the beginning and go to the end without going out of bounds. Most FRQs give you 1 point for trying and then 1 point for doing it correctly. So when in doubt, write something down, never leave it blank. When I say consecutive values, that would be like if you were trying to check if one value was equal to the value after it. So that would be like comparing I and I plus 1. And so in that case, if you're going to do I and I plus 1, you have to make sure that the last value in your loop is 1 less than the end. On the other hand, you might say, oh, I want to do I and I minus 1. Okay, that's great. But then your first value for I has to start at 1. So you always want to make sure you check those edge cases, the first or the last, so that way you don't go out of bounds either on the beginning or the end. So we want to be comfortable with how to replace a regular for loop with a for each loop and when we can and can't use them. With arrays, 1 and 2D arrays, the syntax that you have to know by heart. You have to know how to declare and instantiate this array. how to manipulate a two-dimensional array. So recognizing, for example, that if I say the array name dot length, that tells me how many rows I have. And then if I pick a specific row, so in this case, ARR0 dot length, that will ask me how many columns are in that row. Another thing that many people forget is this guy right here. If I have a 2D array and I give it only one parameter, what that is going to do is that's going to extract that entire row. So just like here, how that gets me the length of row 0, if I just say ARR2D0, that gives me the entire row 0. All right. Let's see. So with our array lists, again, we're going to have access to all these methods on our quick reference sheet. So just being comfortable with how to use them, how to work with them. Some common mistakes people make with our array lists. These three here that are in red, they are in red because they return an object. So what do I mean by that? When I set an object, it's going to replace, and then the item that was replaced is returned. If I get it, obviously that's going to give me the object. And then if I remove an item, the one that I am taking out is returned. So what you want to know from this is that if I am performing an action that will get rid of something in my array list, either because I'm replacing it or I'm removing it, that value that is being removed is always returned. And so that's what these two are showing us here. Okay, so a couple different common errors. So I put these on here because these are things that I see students do all the time. And I've also noticed that they happen to be a common like deduction that people make when, or sorry, not a common deduction. They end up being a common error when let me just start over. Apparently, I can't speak tonight. I've noticed that this mistake ends up being something where people get an extra point for doing it correctly. So in this case, I have a method, and this method is searching for a title within an array of books. And so looking at this, we don't know if book happens to be an array or an array list, this my library, and it doesn't matter because a for each loop works the same both ways. So what this is going to do is it's going to say for every book that I'll temporarily call B, I want to get the title, and I want to see if that title is equal to this title I'm checking. So the issue with this right here is that this is a super common error. It's the return too early error. So this would be like, imagine I had a whole class worth of students and I'm trying to find somebody, and I ask the first person if they're the one that I'm looking for and they're not, and I say, okay, they're not here. Well, no, got to keep checking. And that's what this is doing. So in this case, I am returning too early. This return false should actually be down here after my for loop. In this case, I'm doing an average. And again, this is a super common task that you'll have to do in an FRQ. And so I have an array of ints, which I see here is passed in. And so there's a couple different things that I didn't do correctly here. Does anybody want to tell me one of them, what I did wrong? Any takers?
It's an int instead of a double.
Anybody? Oh, come on. All right. Well,
It's
so first of all, I have this sum variable that I am adding to, but oh, I see a hand coming up. Let's see. Okay, I have not done Zoom in so stinking long. All right. Who's raising their hand? Whoever's raising your hand, just unmute and talk.
the sum variable doesn't exist.
Oh, Ashwin, that's you. Okay. Yeah, go ahead, Ashwin.
The sum variable doesn't actually exist. It's never instantiated or created.
Oh shoot, I had my volume down. All right, can you say that again?
The sum variable doesn't actually exist.
Yes, I never instantiated it. So up here I need to say like int sum. If I just said int sum, would that be enough?
No, because then you can't do plus equals without first having a value.
Yeah, and I mean, technically, the default value for an int is 0. So if you coded it that way, it would work. But best practice is to always give it an initial value. So saying int sum equals 0. And then there's one other issue that we see here. Any takers?
You have to say it's a double.
Uh, so we have to do, oops, we have to do something with the double. So are you saying that I should make my sum a double?
Um, like right after the return, you put double.
Like right here?
Yeah.
Yes. So perfect. So there's two ways we could fix this. Either we declare sum as a double. Okay. So if we're doing our own FRQ, we can choose to do that. Or if we make sum an integer, which is more efficient, then yes, we have to cast it as a double before we find the average. So the way that casting works is casting takes precedence over everything. So if I say double in parentheses right before sum, then what that does is, let's say my sum is 12. Then sum pretends to be a double, so a sum becomes 12.0 for the act of the calculation. As soon as the calculation is done, sum is back to being an integer. So it's not, it's kind of like Halloween where you put a costume on and you dress up for a day. That's like what casting is. I'm costuming the sum. Okay, I'm not making a permanent change to it. I'm just temporarily changing it. All right, let's see. So here we are checking if two consecutive values are equal. We have this array, and we are checking to see if the value at I is equal to the value at I plus 1. All right, so we're not returning too early, so that's good. But what is wrong here?
It'll go index out of bounds.
Yes, I love that you guys are answering questions. Yes, it'll go index out of bounds because here I'm saying I plus 1. So whenever you add a plus 1 or a minus 1 to your indices, you have to make sure you adjust that outer edge. So in this case, since I'm saying plus 1, that means I have to be aware of my outer end, like my bigger end. So here I would just say AR.length minus 1, and then that would take care of making sure I don't go out of bounds. Similarly, if I were to say like ARI equals ARI plus 1 equals ARI plus 2. Like if I was checking to see if 3 values in a row were equal, then this would need to be AR.length minus 2. So I just have to make sure that I account for that. All right. So getting a random number in range. So for something like this, we want to remember that math.random is going to return a double value. So it always returns a double in the range of 0.0 to 1.0. Now you'll note here that the 0 is inclusive and the 1 is exclusive. So what does that mean? That means it's going to give us values that go from like 0.0 all the way up to 0.9999999 until it runs out of digits, okay? Now, there are a couple ways that I can adjust this. So I color coded this here to match these values right here. So if I'm thinking about the range of values, that's going to make my interval that's normally 0 to 1 and make it bigger. So the way that I can make that interval bigger is by multiplying by a constant. Now, a lot of times people get confused about what number to multiply by, and they're typically off by 1. And you better believe that all your answer choices for multiple choice will have all of the variations. So you really need to know this like by heart. So here's how I think through this. Like, let's say I was trying to get a number 1 through 5 to represent the numbers on my hand. Well, I have 5 fingers. Now, if I think about my min is 1 and my max is 5, if I were to do 5 minus 1, that gives me 4. But I have 5, well, I guess I have 4 fingers and a thumb. Regardless, I have 5, whatever you call these, phalanges, I don't know, whatever. I have 5 of these. And so, when I'm trying to include the min and the max value, the 1 and the 5, I have to do the max minus the min, and then I have to do plus 1. So that's what I mean right here when I'm calculating my range. So let's say I was trying to do the example of my hands, the 1 to 5, then that range would be 5, and so that's why right here I would multiply by 5. And now I want my smallest value to be 1, not 0. So in order to do that, I have to offset it. So to offset it, I'm going to add 1. So in my case, this would be times 5 and then plus 1. Now, let's say I wanted this to start at like -2, then I would just say -2. And then the last thing is, if I want my answer to be an integer, we have to cast it. Now, there's a lot of ways we can do this correctly, but there is one way we can do it wrong. Ashwin, question?
Yeah, so you said if both the sides of the range are inclusive, then we have to do max minus one plus one.
Mhm.
If both of them are exclusive, would we do max minus one and minus one?
So you're never going to have the first value not being included. It'll always be, it'll like the way that they'll give the interval is they'll say, like, for example, 3 to 20 inclusive or 3 to 20 exclusive. The first number is always included. So yeah, sorry if that was confusing the way I said that. The first number is always included. So it's just a matter of whether or not that high end number, the maximum, is included. If the maximum is included, then you do plus one.
All right, thanks.
No problem. So what I was saying over here with the typecasting, remember the casting takes precedence over anything else. So if I were to cast this math.random before I multiplied it, then what would happen is it would take this random number that again goes from 0 to like 0.9999, and it would turn into an int, which is just 0, and then it would multiply it by 6, which is then still just 0, and then it would add 3. So in order to correctly cast my random double to be an int, I need to make sure I wrap parentheses around the math.random times the range. Now I can also include this plus 3 inside of it. That's totally okay. But if I don't put in that in there, that's not a big deal. What is a big deal is that I'm multiplying this range before I am casting it. Okay. So I got a couple substring examples here. So a few things to remember about substring. First of all, if I only have one value, remember it starts at that value. So in this case, our indices start at 0. Don't forget that. So 0, 1, 2, 3, 4, 5. Right here is the I. So then it would be is awesome all the way till the end. If I did something like 3 comma 8, remember we talked about how that secondary number here, that higher end, is not inclusive. So it goes up to, but doesn't include that 8. So this would be 8 minus 3, or 5 characters. Now, you might be wondering, well, do I count spaces? Yes, if you hit it on the keyboard, it counts as a space. So I would start at index 3, and then I would take 5 characters from there. So in this case, it would be a space is space, and that would give you those 5 characters. All right, so index of and contains. So index of is super helpful. Recall that index of is going to return the first occurrence. So like if you have a word like, Mississippi, and you're looking for the first occurrence of an S, it's going to give you 2 for MIS, so that first occurrence. But let's say you wanted to know the last occurrence. Well, if you wanted to know the last occurrence, then you could go through and like traverse the string from the end, or you could use a loop and you could keep on going through, substringing it until you had gotten to a position where there was no more S's left. So there are a couple different ways that we can work through it, but it's important to remember that index of returns the first occurrence. Um, Contains is a really helpful method, even though it isn't in the subset. Oftentimes, students ask if they're able to use things that aren't in the subset when they write their FRQs. So when I say the subset, I mean the list of methods that you have to know that are going to be tested on. So if you use something that's not in the subset, like for example, contains, that's totally okay. It just doesn't give you, it's not on that quick reference sheet, but you are more than welcome to use something else. You are discouraged from using things that are like really, that are like crazy, I don't know, like methods that we've never heard of before that we really use. When you use things that are off like that, it just makes it harder for the grader. It's not encouraged. Um, in terms of, let's see, how index of works, again, it returns -1 if it's not found. Contains is just going to return true or false. So that's how that one works there. All right, I'm going to pause for a sec. Do we have any questions? Any questions at all? All righty, I'm going to keep going. Equals and compare to. All right, so equals, you have to always use dot equals whenever you're checking if strings are equal or if objects are equal. Most students don't forget to use dot equals for objects, but they often forget it for strings. And again, in your FRQ rubric, you'll often see that there will be a point simply for, you'll lose a point if you don't use dot equals when you're finding that solution. Compare to is another tricky one that we need to know. So the way that compare to works, remember it takes this first string and it compares it, think of it like with respect to the second string. So it's going to go character by character through that string. And what it's going to do is it's going to subtract the first character and the first character, and then the second character and the second character. And it'll keep progressing through the string until it encounters characters that are no longer equal. So as it's comparing them by subtracting their ASCII values. Now, if you don't remember the ASCII chart, that is okay. You don't need to have those numbers memorized. Basically, what you do want to understand is that it is essentially a numerical value associated with the letters in the alphabet. So even though we don't have to know the exact values, let's just say we say that A is 1, well then B would be 2, C would be 3, and so on. So if I do the word apple minus Cheerios, then I would do, or if I did apple dot compare to Cheerios, I would say A minus C. Well, if A is 1 and C is 3, then that would give me -2. And so when the result is negative, then that means that the string that was before the dot comes before the string that was after the dot or in the parameter. So I often think of it like this string wants to know how it compares to this string. So I'm going to subtract S1 and minus S2. And I'm going to go character by character. And as soon as they're different, if I get a negative, it means that S1 comes first, that it was less than in the alphabet. Whereas if I get a positive, like let's say I did, I don't know, Java dot compare to CSS, then in that case, J minus C, again, I don't care what number I get, I just need to know that it's positive. And that's how I know that the one before the dot comes after the one that's in the parameter. It's also important to recognize that the order of the strings matter. So if you flip the strings, the value that you'll get will just be the opposite, because A minus C is -2, C minus A is +2. So that's another thing to remember. All right. So, in terms of this compare to here with monkey and money, again, as we're comparing and going through them, even though string B and C have the same word, one of them is a capital and one of them is a lowercase. And so I'm not sure if this distinction is something that you have to know, but I do want you to know that if you only say dot compare to, that will give you a non-zero value because in this case, M and capital M, those are different, right? So here, we would just basically recognize that the entire capital alphabet comes before the entire lowercase alphabet. All right, so loops. A lot of these loops, like I said in the beginning, are going to give you 1 point just for writing a loop and then 1 point for not going out of bounds. You never want to leave a loop problem blank, like ever, because you can at least get points for trying to write something. It's kind of like 1 point for trying, good job. Recognizing that the array is dot length and array list is dot size with parentheses. And then the other option is to use your for each loop, which I strongly recommend. Let's see. So working with our objects, I mentioned this briefly in the beginning, but it's important to recognize that an array and an array list are objects and you have to instantiate them before you can use them. Super common mistake in FRQs. If you're writing a class, and I believe that's question number 2 is writing a class, then you declare the variable up top and then you instantiate it in the constructor. You never declare variables above the constructor in a class unless they are static. That is the only time you give them initial values before the constructor. Let's see. When you're adding an object to an array list, there's a couple different ways that we can do this. So in these first 2 lines here, I made a book variable first, and then I just said dot add this book object to my array list. Another way that I could do this is I can call my book constructor inside of my add method. So if you're looking at solutions for FRQ problems, they often use this strategy down here, but these 2 lines up here work just as good. It's just a matter of personal preference. Recognizing how to use the percent 10 and the divide by 10. So when we say modulus 10, remember that's going to give us the ones place. If I said modulus 100, that would give me the last two digits, or like the tens place. If I wanted to remove a specific value, then the way that I remove it is by dividing by that number. So just keep that in mind when you're working with problems that involve digits, because that's another common thing you will see. Um, let's see. All right, so static variables and methods. So if you're using a static method, it means that you have to call it by class name. So in this case, like if I wanted to use the power method, that's a method of the math class. So I would say math.pow. If you're using a static variable, that belongs to the entire class. So what that means is that every variable in the class has access to that, and they're all going to have the same value. So like if you change it for a 1, it gets changed for all. All right, printing versus returning. Sorry, I'm trying to find my charger. There we go. Printing versus returning. I don't know that I've ever seen an FRQ problem that involves printing, and that is a really common mistake. So if you think you're supposed to print, you're probably doing something wrong and you're supposed to return. So really read carefully to make sure that you don't misunderstand that. I know students are always like, oh, can I use SOUT for my FRQ? And my best answer to you on that is no, because you shouldn't be printing. So remember that. Okay, so I feel like I went through that very quickly. I know D Steph and I have been doing review for the last like week and a half, 2 weeks. So I'm hoping that a lot of this was pretty like it made sense as I was going through it. Do we have any specific questions at the moment?
The contains method, does
Mhm.
that care about capitalization or uppercase versus lowercase?
Great question. So the contains, the index of, and equals, all of those do care about capitalization. So if you want to check if it's just there, regardless of the case, I don't know if there's a contains ignore case. I'm guessing there isn't. What I would probably do is take my starting string and just make it lowercase, and then my input to contains lowercase so that I can compare lowercase with lowercase.
Okay.
Any other questions so far?
Can you go over one more time the difference between dot equals and the double equals?
Yeah, for sure. So with let's see, do I have that written anywhere? Okay, so equals equals is going to compare primitives. So like if you have ints, doubles, booleans, those are the only primitives that we need to know, and those you compare with equals equals. We also use equals equals to compare address references. So like if you're trying to see if one pointer to an object and another pointer are both pointing to the same object, that would be another time when you would use equals equals. Dot equals is a method that you can call from an object. So our string class has dot equals defined for it. So when we use dot equals for strings, we can just say like str dot equals, col or whatever. And then that will just use the equals method of the string class. If I have my own class that I wrote, for example, like a book class, I would have to write my own dot equals method in order to see if two book objects were equal. And the reason why is because equality for objects depends upon how the programmer wants to make them equal. So like I might say that if the book has the same title and author, it is equal to another copy of the same book, even if it was maybe printed 2 years later. It's still the same book, right? So in that case, my book class might have different variables for each book object, but I like maybe like condition or copyright year or whatever. And I might not care about that. I might only care about the name and the title or the author and the title. And so that's where when you write your own equals method, you can specify that. Um, so does that help?
Yeah, thank you.
Okay, cool. No problem. What else? Other questions? Do we feel comfortable with when we can use for loops and for each loops? Is that something you want me to go over in more detail? Or anything else in general?
Yeah.
Yeah? Okay. Give me just a sec. I'm gonna switch over to my iPad so I can write on it. Again, bear with me. It's been a hot minute since I've done this stuff. I had like such a good system going during COVID, and thankfully now I don't anymore, but I feel all out of sorts. Okay. All right. So let me see. I think I can share my screen from this guy. All right, here we go. Okie doke. All right, so if I have, let's say I have, let's just say I have an int array, and we'll just call this nums, and we'll say it has a size of 5. Now, if I wanted to fill my array, let's say I wanted to make my array equal to, I don't know, multiples of 5. So 5, 10, 15, 20, 25. Then I could say, for example, for int I equals 0, I less than nums dot length, I plus plus. And notice the way that I'm writing this for loop, like you should be very comfortable with declaring an array, with writing an array loop header. Like this should be something you can do without even thinking about it. And so now inside my loop, I can say, all right, well, I want to make every entry in nums. So nums bracket I, and I want to make it equal to the multiples of 5, starting with 5. So I'm going to have to do I plus 1 and then times 5. So what this is going to do is it's going to fill my array. Now, at this point right now, I can essentially say that nums is pointing to a storage with these values. Now, if I were to say on another line of code, let's say I were to say, for example, int array nums copy equals nums. What happens here is that we think, based on the name especially, that I am copying the array, but I'm not. What I'm really doing is I am making another pointer. I can hear my husband and my kids playing video games upstairs, and they're fighting. Sounds like I'm missing out on some good times. Okay, so I made this this copy, and essentially I'm saying this is going to point to the same array. I haven't actually copied the array. I've made a copy of its address. So now in this case, if I were to say, for example, if nums equals nums copy, I could print out point to the same place. And so in this case, that would print out. That's what I would see, because nums and nums copy point to the same location. They are like two different keys for the same car. Just because they're two separate fobs or two separate keys doesn't mean that it's two different cars. When we wish for that. No, it's two different keys that open the same car, and that's what's going on here. Now, if I were to make a change now, and I were to say, for example, if I were to say nums copy 3 equals, I don't know, 100, then what's going to happen is if I look at these indices, remember we start at 0, I'm going to go to index 3 and I'm going to change this and replace it with 100. And then if I were to go ahead and print nums 3, this would print out 100 because I have actually replaced that value. Okay, so now this is kind of like talking about just the whole idea of the two reference variables pointing to the same place. So let's say I had another scenario, and in this case, let's say I made an array, and I just called it ARR equals new int of size 20. If I tried saying, for example, for int a in ARR, a equals 6, that's not going to do anything because essentially what I just did, here, I'm actually going to make this size smaller so that I can draw it out and not have it be so big. What I did here is I made my array reference, and then I made my array storage space. And recall that the default value, when you make an array has to be filled with something. So for ints and doubles, it's filled with the default value, which in this case is 0. If it was a Boolean, it would be false, and if it was an object, it would be null. So at this point, right here, at this point of the code, what's happened is that I have all of these values are 0. Now, let's say I were to go ahead and run this code right here, this for each loop. What's happening is that a for each loop creates a temporary variable that exists for the duration of the loop. So when I start out, a is this temporary variable of 0 because it's an int. And then I make it equal to 6. And then that iteration of the loop is done. So now it's wiped out and I start all over again. Notice I didn't make any changes to ARR. Okay, none. So this is an important thing. You cannot fill any array. Oh my goodness, I can't spell. Any array, 2D array, or array list with a for each. It simply will not work because the whole idea behind this for each loop is that it's making a temporary pointer to a value, and each time it iterates through, that value resets. So you cannot use a for each loop to initialize an array list, a 2D array, none of them. Now, let's say I had this existing array. So before I continue, do you have any questions? Okay. So remember that we can create an array from an initializer list. So let's say I said int array ages equals 15, 16, 12, I don't know, 9, and 20. Okay, so in this case, Java says, okay, you want to make a reference to an array, and so it's going to create this reference to the array, and based on these 5 values, it's going to create this array. So I'm going to have 15, 16, 12, 9, and 20. Now, just like up here, if I were to say for int a and ages, and if I were to say, oh, hey, everyone gets a birthday, and I were to say a plus plus, again, that's not going to do anything. There will be no lasting change to my array. What will happen here is it will say a, and the first time through, a is equal to 15 because a is equal to the value in the array, and it will increase it by 1. So now that value will be 16. And then I will have finished that cycle of the loop. So now that value is gone, and I start over again. And now I'm on this guy here. So I make a 16, increases to 1, and now it's done, and I go on to the next value. Notice nothing is changing in my array. So when you're working with these primitive values, and remember, primitives are like your ints, your doubles, your booleans, the for each loop cannot be used to make any changes. It can only be used to access consecutive values. So let's say I wanted to find the average age. In that case, I could use this for each loop. I could say something like this, and I'm pretty sure I had something like this in the initial note slides. And I could say, int sum equals 0. And then inside my for each loop, I could just say sum plus equals a. And so what that will do is as it loops through the array, each entry will take a turn being equal to a. So the first time a, so if I have my sum and it's equal to 0, and then the first time a is equal to 15, and I add 15 to that. So now sum is 15. And then the next time through, now at this point, A is equal to 16. So I add 16 to that. So now sum is equal to 31, and it continues on building. So this is a great time to use a for each loop. If I were to have done this with a regular for loop, it would look like this. I would have for int I equals 0, I is less than ages dot length. Oh, I forgot my I. See, look, I already made a mistake. I equals 0, and then I plus plus, and then I would have to say sum plus equals ages bracket I. See how much more work that is? It's just a lot, and it gives you more opportunities to make mistakes, and it also just takes longer to write. And if your handwriting looks like mine, then you know, I mean, the left one looks a lot prettier. Okay, so now the question is, well, when can I use a for each loop to make changes? So that happens when you're dealing with an array of objects. So let's say we were talking about this book class. Okay, so let's say I had a book array and it was called like, we'll just call it the library equals, and then we'll say new book. And then let's say we had 1,000 books in our library. Okay, and let's just say we filled the library. I'm not going to write all that down. And let's say somebody said, oh, my English class is going to read Just Mercy. How many copies of Just Mercy do you have? I want to know if we have enough in the library. So then what I could do is I could say for each book, which I'm going to temporarily call B, I want to do the inside my array library. I want to do the following. And let's say we wanted to not only count how many there were, but we also wanted to check them out. So since we're going to be doing multiple things here, we'd have to use our curly braces. And I could say, for example, if B dot, and again, I'm just kind of making up these methods. I'm just assuming I would have a dot method, dot title. And then because I'm comparing strings, I would have to say dot equals. And again, in this case, we're looking for Just Mercy. Okay, so if the title of the book in the library is equal to Just Mercy, then I want to do two things. Number one, I want to count it, and number two, I want to check it out. So then I would say count plus plus, and then I would say b dot checkout. And so the question becomes, well, what is this doing? Well, it's taking my entire array of 1,000 books, and for every book that's in this array, if it is a copy of Just Mercy, it's going to count it up, and then it's going to check it out, so that way nobody else can take it. And so when I have finished this for each loop, the actual books will have their value, their attribute for the checkout status checked out. Now you might have additional like places in there, like if it's not checked out, we're just assuming everything's available. Okay. And so in this case, if I were to have a book and it was literally like the title, the author, all that stuff, each time through, B points to a new book. And so if I say dot checkout, then maybe my is available would be false. And I'm going to change it to false. And when I leave this loop, when I'm all done, the actual value at that address is changed. An example of this would be like, let's say, again, let's talk about the keys to the car, right? So you've got your main keys and then maybe you have your backup keys. So think of this for each loop as like your backup key. So somebody took your backup key, they drove your car down to U of I and back, and they came back and you had an empty tank of gas. When you get in the car the next day with your keys, your car's still empty because somebody drove it and changed it. And that's what's happening in a for each loop with objects. With objects, you can actually change what you find when you get there. All right, let's see. What other questions do we have?
Could we go over 2D arrays?
You bet. Anything in particular or just a general overview?
A general overview.
Okay. So when you think of a 2D array, you want to think of it almost like a rectangular grid. Okay. And so when we declare them, and I'm just going to stick with integers just because they're simple to write. If I had an int 2D array, first of all, I need double brackets. And I'm just going to call this ARR2D. And if I just stop here and put a semicolon at this point, ARR2D is currently pointing to nothing, so it's null. If I tried to set a value within this, it wouldn't do anything because there's nothing to set it. It's kind of like if you had the idea that you wanted to build a storage structure, but you hadn't built it yet. If it's not built yet, you can't put anything in it. And that's what happens when you haven't instantiated it. All you've done is made the idea that you want to build it. So let's say I decided to go ahead and instantiate it. And so I said ARR2D equals new. Remember, whenever we're making an object, we have to have that keyword new. That is how we set aside memory. So equals new int, and then we'll give it a size. We'll say 2, 4. So at this point, the first number is our rows and the second number is our columns. And so instead of having this refer to null, now I am referring to this rectangular grid with 2 rows and 4 columns. And again, because this happens to be an object, and the way that an integer constructor works is when I make an integer, I'm going to fill the entire thing with zeros. So all of these values are equal to 0 at the beginning. Okay. Now, if I wanted to change those values, I have to either do them one at a time. Like I can say ARR2D, I could say 0 and then 2 is equal to, we'll say 8. So in that case, this is row 0, row 1, and then column 0, 1, 2, 3. So when I say that I want to go ahead and find 0, 2, that's going to be this guy right here. And if I want to change that value to be equal to 8, then I will now have made this equal to 8. Now, let's say I wanted to write a loop to go through and make each value equal to the sum of its indices, right? So like basically row plus column. So in that case, my outer loop, I would say for. Now you can write the indices whatever you want. I usually use R and C for rows and columns. If you're looking at multiple choice problems, you won't always have the choice of what you want to use. But if it's your FRQ, I would suggest using R and C or row and col so that you don't confuse yourself. So I'm going to say int R equals 0, and then R is less than. So we say array name dot length, because that is equal to the number of rows, and then R plus plus. So what that's going to do is say, okay, start at the first row and then do the following. So if I'm thinking about this from the perspective, where's my little pointer? Is this my little pointer? Yes. Okay. So if I'm thinking of this from the perspective of I want to go here to here to here to here, what this first line is doing is it's saying, get me a row. And then once you have a row, what do I want to do with it? Well, I want to visit each value one at a time. So now my next part is I'm going to say for int C equals 0, C is less than. Now at this point, remember, we're referring to a specific row. So when I grab this first row, when I say this first row dot length, that tells me how many columns there are. So in that case, I want to say ARR2D, and then you can use any valid row here. I usually just do 0 and then dot length, and then C++. So it's important that we recognize that this number here tells me the number of columns, and this tells me the number of rows, and you should absolutely know that. And if I wanted to make each value equal to the sum of its indices, then inside here, I could just say ARR2D R C equals R plus C. And then that will go ahead and that will fill my array. Now, if I wanted to, let's say I wanted to print my array and I wanted to print out its values. So in this case, its values, after running through this code, I would have 0, 1, 2, 3, and then 1, 2, 3, 4. That would be my array values. So let's say I wanted to print it to look like that. So print a number, give a space, and do that for the whole row. And then when I finish the row, go to the next line. So in that case, I can totally use a for each loop. And I would recommend that because a for each loop is simpler, it's less to write. If we look at the code I just wrote in blue, that code is much more complex. So if I were to do this to print the array contents. Then the way that I would do this with a for each loop is I would say for, now I'm essentially grabbing an entire row. So I'm saying I'm going to grab this whole row. And so when I grab a whole row, that is a 1D array. So I'm going to say int bracket, I'm going to give it a temporary name. And because it represents a row, I'm going to call it row. Inside my entire array name, ARR2D. And so what that's going to do is that's going to grasp an entire row. And then for each one of those elements in the row, those are singular ints. So if I have my 2D array, a row is a 1D array, and a value in the row is an int. So now here I would say for int A in my row. And so when I say that, I'm essentially saying one of these values. And then if I wanted to print that value out, again, we're not going to be writing print statements in our FRQs, but you will see them in the multiple choice, and they will never write out. They will always write system.out.print, and we need to know print versus println. In this case, I would want to do print. Println is going to put a return at the end after printing. So since I don't want to return until I have finished the very last value in my row, I'm going to use print. And I could say print A and then plus a space. And then what this will do is it will print the 0. And then the next time through, the A is going to equal 1. And then the next time A is going to equal 2. And then A will equal 3. And then once it finishes, then at that point, there is no more A. And now what happens is that row is equal to this row down here. And then we repeat the process where we have A is equal to this one. And then A is equal to 2 and 3 and 4. Now you'll notice that when I change the highlighter for the green to go to the next line, it's literally another line. So I have to go down a line. And the way that I do that in my code is I have to tell it to do a println after that inner loop, but before I repeat my outer loop. Let's see what else. With your 2D arrays, the way that they're represented in memory is essentially like an array of arrays. So if I were to, again, look at this array 2D in memory, like if you look at this in debugger, and we refreshed on debugger during our recursion chapter, if you were to look at this, each one of these entries is essentially its own row array. So that is why we typically traverse 2D arrays going row at a time, because that's more efficient for the computer. It's just how the computer thinks about it. But you can traverse a column at a time. And so if you wanted to go a column at a time, that is a different type of traversal. So when you are going row by row, that is called a row major traversal. I'm pretty sure we had an FRQ that used that terminology, and some people were confused by that. If you go column by column, similarly, that's a column major transversal. So let's say I wanted to traverse this ARR2D column by column. Okay, well, if I wanted to do that, I can't use a for each loop, because the for each loop, again, the way this works is it snags an entire row. But because of how these are stored in memory, you can't just snag a whole column. It just doesn't work that way. So if you're going to have to go column by column, you have to use the traditional for loop notation. So for that, I'm just going to copy this for the sake of time. So for that, if I was using this notation, the problem here is that this is going to tell me to start and grab the whole row and then grab the column, but that's not how I want to do it. I want to go column, and then once I'm in column 0, I want to then go row 0, row 1, row 2, and so on. So if I wanted to do a column major traversal, then this actually comes on the outer edge. And I would say, okay, first grab me a column, and then within that column, one at a time, grab me a row. So if I were to take this I were to take this diagram and bring that back down here, and we were to do this, then first I would say, okay, get me a column. And then within that column, I want you to grab me each row. So first, get me row 0, do whatever you got to do. Then get me row 1, do whatever you got to do. Then, oh, we finished the whole column. Okay, so now I'm going to move over, and now I'm on column 1, and I'm on row 0. All right. What other questions do we have? Let's see. So there's a question on searches and sorts, and I see Ethan has their hand up. So, Ethan, what's your question? And then I can work on searches and sorts.
So are they gonna like tell us if like we have to use the for each loop, or like can we do whatever we want?
So when you're writing an FRQ, you can write whatever kind of loop you want. So if you don't prefer for each loops, if you prefer a traditional for loop, you can do that whenever you're writing an FRQ. However, you will see some multiple choice problems where they'll give you a loop and they'll say which of the following do the same thing. And they will mix and match for loops and for each loop. And so that's why it's important to feel comfortable with the different notation. You do have to know like some of the areas I was talking about in the beginning when you can't use a for each loop. And that's when you are filling an array, or excuse me, when you are changing the values of a primitive array. If it's an array of objects and you're updating values, you can use a for each loop. Let's see, Ashwin, question.
Yeah, so you said the 4 FRQs are like control structures, class writing, 2D array, and array and array list. But for like the class, is it possible they could ask you recursion or inheritance in the class, or is that only MC?
Can you say that one more time? They'll only ask you what in the class?
When they ask you to write like the methods for the control structures, or they ask you to write the whole class, will they ever ask you to write some stuff involving inheritance or recursion?
So they will never ask you to do recursion in an FRQ. That's only tested in multiple choice. Your class writing question could include inheritance, as could your control structure. So inheritance is kind of like fair game in any one of those topics, because, you know, if you think about it with inheritance, you might have, or even like with your class writing or method writing, you might have an animal class, and then you might have a cow subclass, and you might have to write a method of the cow class that overrides something from the animal class. So you definitely could see that in your FRQs. The nice thing about knowing those 4 different topics for the FRQs is that you know that you will for sure have to write a whole class, and you will for sure have one problem that's dedicated to manipulating arrays or array lists, and then one that's dedicated to manipulating 2D arrays. But that doesn't mean that those are the only places you could see that. It just means that it's dedicated to that.
All right, thanks.
And if you look at the last, like the 21, 22, and 23 FRQs are probably the best indicator for what those 4 categories of problems will look like, because that's when they changed the ruling of what each of the 4 problems would be. Prior to 2020, in 2019 and earlier, that's when they didn't have those rules. So it was kind of like all over the place. And that's why they created those rules. Let's see. So there was a question about going through the searches and the sorts. So in terms of our searches, we have 2 searches that we need to know. We need to know our linear, and we need to know our binary. Linear is basically going to say, okay, I have an array list or an array, or a 2D array, and I'm basically going to start from the beginning and just go element by element until I find it. It's not very efficient, but it's very easy to write. This is definitely fair game for something on an FRQ. You could be asked to find the index of where it's located. You could be asked to return true or false if in the array. You could be asked to count the number of occurrences Another example would be to find the location of the last occurrence. Okay, I can't spell, that's why I code, so we'll just abbreviate that one. Okay, so of those scenarios in the linear search, is there any one of those that you all want me to walk through how the code would look for that?
The location of the last occurrence.
Sure. Okay, so let's say we have an array, and let's say I have my int array, and in here I have the numbers like 2, 3, 2, 1, 6, 2, 4, 8. Okay, and let's say I want to find the last occurrence of 2. So an easy way and a hard way to do this. If I want the last occurrence, the easiest way to do this is to start at the end and say, okay, I'm gonna check the last value and then the last, and keep on working. And so if I'm looking for a 2, as soon as I find a 2, I know that that's the last 2. If I get all the way to the beginning and I haven't found any, then I know it doesn't exist. This is much easier than trying to like keep track of where you're at and know that you are on the last. So when you're trying to find the last of something, starting at the end of the array is always the easiest. In terms of the syntax for that, the way that we would say start at the end is, and we have to use a for loop for this because remember, a for each loop starts at the beginning and goes one by one until the end. So if we want to switch the order of our traversal or we want to go like every other, we have to use a regular for loop. So if I want to start at the last index, remember if my index, let's say my length is 20, my last index is 19. So it's always going to be length minus 1. So I'll say for int I equals ARR dot length minus 1. And then that middle condition is what we check to make sure we keep going. So I need to make sure that I is greater than or equal to 0. Common mistake here is to say less than. It's never going to be less than or else it wouldn't run. And then now I need to decrease, so I'm going to go down. And then I could basically just say if ARR bracket I is equal to, I'm just going to say target, whatever number I was looking for. If it's equal to that target value, then I would just say return I. Now, sometimes people think if they have an if, they have to have an else. That's not true. If I'm going through this array and I'm trying to find the last occurrence, and I say, okay, I've checked this guy. Is it equal to my target? No. I checked this. Is it equal to my target? No. I checked this. Is it equal to my target? Yes. So then I want to return that value. Now, let's say I was looking for the number 7. 7's not there. I get all the way to the beginning. If I get all the way to the beginning and I'm still in my my method here, then in that case, I know that it's not in my array. And so then that is when I would just return, again, spelling, that is when I would just return -1, which is our standard like ruling for not found. All right, let's talk about our binary search. So with binary search, you will not need to write the code. Okay, you're not going to see this on your FRQ of code writing. That won't be there. Linear, absolutely. I just showed a number of ways that you could see a linear search that could be working, but binary, this is more likely to be seen on your multiple choice questions. So what are some ways that we could see this? It could ask you to give the index returned. And typically you'll see that when you are searching for a value that is duplicated. And the reason why I say that is because if the only thing you had to do is look at an array of numbers that are in order and tell, and the answer is which index is it at, you could just look and tell. But if it wants to know which index it is when there's a duplicate of it, then you have to understand how that algorithm works. So other ways that you might see this tested is it might say how many times does the search like recursively call. That's another thing that you might see. And so again, our idea of binary search is it's going to divide and conquer. So it finds the middle index. If the middle index is too small or too big, it cuts off half of the array and then just repeats that process. And it repeats that process until it gets to the point that the low index is no longer less than or equal to the high index. As soon as that low index is greater than the high, we know that we have flip-flopped and we've missed it because it's not there. And in that case, you return -1. Would anyone like me to go through an example of how you would go through binary search? Okay, so for our sorts, there are 2 different sorts that we need to know. There is selection and there is insertion sort. Okay, so what do we have to know with these? First of all, these will not be on your FRQs. You will definitely not have to code this from scratch. But you do need to be able to recognize when there's something missing or know how the algorithm works. Some common questions that I've seen is they might give you the algorithm and then they'll have like you know, a comment that says like, for example, line A, or it might say line 8. And the question might say, how many times in the sorting of this array does line 8 execute? And what they're looking to see is if you understand how the algorithm works. So to show you what I mean by that, let's just real quick recap the sorts and then I can pull up a question or two. So our selection sort is going to start with index 0 and it's going to find, I'm just going to go from smallest to largest, the smallest value, and then it's going to swap into position 0. And then after it's done that, position 0 is done. It does not move again. And then we repeat this with index 1, index 2, and so on. So we're going to have 2 for loops. The outer for loop is going to go from 0 to the last value -1. And then the inner for loop is going to be 1 greater. Actually, you know, I'll just, it's going to be 1 greater than the outer, and it will go to the end. Okay, and so basically what's happening is it's going to check and say, hey, are you smaller than me? Are you smaller than me? Are you smaller than me? It's going to go all the way to the end to find that target element. And then when it finds a target element, it's going to do a swap to put the one where it belongs. So if we were to just write a quick array of values, so if I had 6, 2, 7, 0, 5, 3. And if this were my array, then I start out saying, okay, 6 is the smallest number, woohoo. And I would start with that as my smallest number. And then I would compare 6 with 2. And it's like, oh shoot, 2 is the smallest. So right now I'm essentially keeping track of where my smallest value is. So now my smallest value is at position 1. And I'm going to keep on going through and comparing. And then I check the 7. Is 7 smaller than 2? No, it's not. So then I go to the 0. Is 0 smaller than 2? Yes, it is. And so essentially what happens as I go through this process, I find that smallest value, and then I swap it with the value that I am selecting for. And so at this point, after my first iteration, what my array looks like is 0, 2, 7, 6, 5, 3. And at this point, that value is fully sorted and it's not going to move again. And so now I repeat the process, and now I'm doing this for the 2, and I check if 2 is smaller than anything else left, and it's not. So selection sort actually swaps with itself. This counts as an iteration. And so now I have 0, oops. I have 0, 2, 7, 6, 5, 3, and now 0 and 2 are fully sorted. And so as I continue with this, the 7 is going to swap with the 3. And now these 3 are fully sorted. So what I want you to notice is that after 3 iterations, the first 3 values are sorted. The reason why this is important to recognize is because sometimes you'll see a question where it says, using selection sort, what would the array look like after 4 iterations of the outer loop? That's what they're testing. They're testing to see if you know what happens row by row, not that you can put a few integers in order. And so a common mistake where people goof on something like this is right here. They see no change, they think it doesn't count, or they don't write anything down, and so then they end up going 1 line too far. So that is our selection sort. This is the one that I often call the stupid sort because it will swap with itself even when it doesn't need to. Also, if you were to give selection sort a fully sorted array, it would still do the entire problem. Gotham, do you have a question?
Yeah. Wouldn't it be 4 iterations for that? Like, does the first one not count?
Well, this is like my starting array. So like this is what I started with. And then after the first iteration, when I is 0, after that round, the ith position or the position 0 is sorted. So one time through, this would be the first iteration, this is our second iteration, and this is our third iteration. This is what we start with. All right, so with our insertion sort, this is the one that's a little bit more intelligent. Just go down here. So insertion sort, this is our adaptive sort. So the nice thing about this one is insertion sort only does work if it needs to. So this is the one that's going to assume the first value is sorted. And what it's going to do is it's going to compare each value next to it and see if it needs to slide to put it into the right place. So if we were to start with the same array that I had up here, and let me make this, so my starting out, if I were to start, so 6, 2, 7, 0, 5, 3. So this is the initial problem. And then on my first round of doing work, I start assuming that that 6 is sorted. So the first time through, I start with this value. So insertion starts with I equals 1 on that outer loop. And then inside on my inner loop, it says while, and it starts comparing with the values in front of it. So I'm going to compare and essentially see, am I in the right place with respect to the values that come before me? And I'm not. So this 6 is going to shift over to make room. And then the 2 is going to say, okay, well, what comes before the 6? Oh, there's nothing there. So now it knows that this is where it gets inserted. And so now I have 2, 6, 7, 0, 5, 3. So this was after my first iteration. So after my first iteration, I have 2 values that are sorted with respect to themselves. Now, on my next time through, I am going to compare the 7. And the 7 is going to look to its neighbor to the 6. And with respect to the 6, 7's in the right place. So nothing happens. That iteration is done. Now, again, we need to make sure we remember that it still counts as an iteration even though nothing moved. So this still counts as a row. This is how it looks after my second iteration and the first 3 values are sorted. And then now I go to the 0. And the 0 says, okay, well, I need to make room for me. Well, in order to make room, the 7 has to slide over, 6 has to slide over, the 2 has to slide over, and there's no more values left. So then the 0 can insert here. And so now I'll have 0, 2, 6, 7. And again, this is after my third round. The first 4 values are sorted. So with insertion sort, after k rounds, the first k plus 1 values are sorted with respect to each other. So when I say sorted with respect to each other, notice that with insertion sort, all those later values, they haven't even been touched yet. I haven't done anything with them. All that I have done has been starting with first shifting and moving position 1, and then shifting and moving position 2, and then shifting and moving position 3. So the stuff on the right end hasn't even been touched. And that's different from my selection sort. If you look at my selection sort, those values on the right end, they're moving all around. And so it's quite possible that I could have the smallest value. Like I could still be moving things around. And that's why it's important that we recognize that with selection sort, after the first K turns, the smallest K values are where they belong. Whereas with insertion sort, after K turns, the first K plus 1 values are sorted with respect to themselves. And this is helpful because let's say I gave you an array of 4, 2, 1, 6, 8, I don't know, 0. And I said, with insertion sort, what would it look like after 3 rounds? Well, what you can do is you can say, oh, okay, well, with insertion sort, I know after 3 rounds, the first 4 values are sorted with respect to themselves. So let me just take these 4 values and put them in order. 1, 2, 4, 6, and then these 2 haven't done yet, and that's it. So you don't even have to trace the code. So that's just a nice little tip to remember with our insertion sort. And then the last sort is our merge sort. And merge sort, you will not need to write the code. So you're not going to have to write that on FRQ. It's going to be multiple choice only. And essentially what we need to know for merge sort is it's going to recursively cut your array in half until it gets down to base case. And base case would be 1 element and 1 element, and then they merge back together. So the way that you might see something like this would be, so let's say in this case, I have an array of 3 elements. So if I break it in half, I first would break it down and have these 3 on the left, and then I break it in half again. And if I have an extra element, that extra element goes to the left. So now I have this guy, and then I break it in half. So I get a 2, and 2 is base case. I can't go left anymore. So now I go right. Base case, I can't go right anymore, or I can't do anymore. So now these 2 are going to merge together. And when they merge, they go in order. So 1, 2. And then now I start saying, okay, well, where am I at now? And so now that I have finished this like branch, so to speak, that means that for this 3-piece array, I have finished going left. So now that I've finished going left, that 3-piece array is ready to go right. And I've reached base case. So now my big 216 has gone left, has gone right. And so now it needs to merge back together. So these are going to come together in 1, 2, 6. And then now if I consider my big 6-element array, my big 6-element array has finished with its left. So now it's ready to go to the right. And so now I'm going to do the same thing over here. And then these are going to come back together. And then I'm going to have the 5. And then these are going to come back together. And looks like my kids want to say goodnight. All right, come on, quick. You want to say hi?
Not
All right, there's my little guy, Brayden. Come on, Riley. Let's go. Chop, chop. Oh. All right. I love you, baby. All right. Sorry about that. And then I told you it'd be good luck if you got to see my kids. So you're all lucky now. And then now we go ahead and we put these 2 together. And so that would be your final merge. And when we do a final merge on these, we have 1, 2, 5, 6, 7, 8. If we have an array of size n, there are always n minus 1 merges. All right, what else you got for me? Go through double recursion. Okie dokie. Give me just a minute to find a problem. Let's see. So things to remember with our recursion are like when we're printing and like when we've reached that base case. So let's say I had a function, and I'm just going to call this test, and it's going to take in a variable, and then we're going to say if n is greater than 1, I'm going to do test of n minus 1, and then test of n minus 2, and then I'm just going to print out n. Okay, so in a scenario like this, we've got 3 different tasks that are happening. And so the first thing you want to do is ask yourself, what is my base case? So my base case is going to be whenever n equals 1, because as long as it's greater than 1, I keep going. If it equals 1, I stop. So I would often write off to the side, when n equals 1, I'm going to stop. Or if n equals 0. Both of those scenarios I can end up happening. In those cases, I would go ahead and I'd stop. So let's say I asked you to do test of, we'll just keep it simple and say 4. So I would come into my array and I would, or my function call, and I would say, okay, is 4 greater than 1? Yes, it is. Okay, so I have 3 tasks that I need to do, and I often do these like going left and going right. Some people do like 3 different lines. Again, whatever works for you, whatever you did during the chapter, continue with that same style because you've already perfected. So I'm going to say, okay, I'm gonna go test, and I'm gonna do n minus 1. So I'm gonna get test of 3, and at this point, 3 is still greater than 1, so I'm gonna go it again. Each time I enter the function or the method and I start over, it's a brand new start from scratch. So now I'm at test of 3. So I ask myself, is 3 greater than 1? Yes, it is. So now I do it again. So I'm gonna have test of 2. Is 2 greater than 1? Yes, it is. So I got to do it again. So I'm going to have test of 1. Now, I have reached base case. So since I reached base case, this one is done. I can't do any more with it. So now I go back up to test 2 and I say, okay, I'm waiting for more instructions. I already did this n minus 1. Now I have to do test of n minus 2. So 2 minus 2 is 0. So I'm going to try test of 0. Once again, 0 is not greater than 1. So another base case. So now I have done for this test of 2 node, so to speak, I have done the first task, I have done the second task, and now I'm ready to go ahead and print. So at this point, I'm now going to print out what my n value was. So I'm going to make a separate line up here to keep track of my printing. I'm going to print out 2, and now I have done all 3 of these tasks. So now this node is completed. Now you might find it helpful to put a little X through it. Maybe you don't. I don't know. I know some people found it helpful when they put like little dots on the actual method call. So I'm going to show you what I mean by that. So right now I've already done for test of 3. I've done n minus 1. Now I've got to do n minus 2. So this will give me test of 1. So that's my next task. I took care of that one. 1 base case. I don't need to go again. I'm going to X that off. So now this node, its third task is to go ahead and print that value of 3. Now, if I go back up to my test of 4 has finished with its left branch. Now test of 4 has to do n minus 2, which is test of 2. So now it is currently in that branch. And so now test of 2 starts over, and it needs to go n minus 1, which is my base case. And then I'm going to do n minus 2, which is another base case. And now I'm going to go ahead and I'm going to print my 2, which goes right here. And then now I have finished this node. It has done all 3 of its tasks, and I can go back up to test of 4. And the very last thing that test of 4 needs me to do is to print out this 4. And that is how I get this answer here. Is that what you meant by double recursion, or were you wanting me to do a different type? Cool. All right. What else? Other questions?
can you go over inheritance and polymorphism?
For sure. All right, so with inheritance, there are a bunch of things to remember. So first of all is the whole idea of like the parent class and the child class. So if we were to, let's see, we had a lot of examples in class. We had like the animals, we had the vehicles. Let's just say we had, what's another example? You know what, I'm just gonna do the animals because that's a pretty easy one to do. And so if I have my animals, and then I have a water animal, and I have a land animal. And then actually, you know what? No, that's getting too complex here. That's thinking too hard for 7:30. We'll just say that we have a dog and we have a cat. And then I can even go like more specific and say that my dog is a poodle. Okay, it's a specific kind of dog. And so let's say my dog has a method that, or my animal has a method that is called make noise. And let's say that my cat overrides this method and also has its own method, which is use litter box. And let's say my dog also overrides make noise. And then let's say it has a method that is called go outside. Okay, now clearly an animal can call the method make noise because it's declared at the top level. Let's say my poodle does not override methods. Let's say poodle just has a method that's called like go to groomers. Not saying other animals don't go to the groomers, but we're just pretending we have a little prancy poodle and he gets all groomed up. So if I were to have, for example, animal A equals new cat, that's okay because all cats are animals. So I can say generically, oh yeah, that animal over there, whether it's a dog, a cat, or a poodle, calling it an animal makes sense. I can't point to a dog and say, oh, that poodle over there. Not all dogs are poodles. So that would not be correct. If I said a dot make noise, that is okay because all animals have a definition of how to make noise, whether it's the generic method that maybe just says make a sound, or the specific overridden method that says meow or woof woof or whatever. Now, if I were to say a dot go outside, that doesn't work for a couple reasons. Number one, because cats don't have that method. So let's say you said, oh, okay, well, since it's a cat, I'm going to say a dot use litter box. That is also not okay because as far as Java knows, this animal or this A is an animal and not all animals can go or can use a litter box or go outside. So it won't even let the code compile, even though A is actually referring to a cat. So in order to make this compile, we have to cast it. So you're basically saying, hey, I know that this is actually pointing to a cat. So because it's pointing to a cat, I want you to treat it like a cat and tell it to use litter box. So in order to do that, you have to, first of all, put it in parentheses to cast it. Then you have to say what you want to cast. And then you have to put another set of parentheses around it before you call the method. And this is important because the dot operator, this guy right here, takes precedence over the cast. So if you don't put it in parentheses, it will not cast it before it tries to use it, and it will not work. So this right here is how we want to do it. Now, let's say we had a method that hold on a sec. Let's say we had an animal or a method. The most common mistake that people make with these types of problem sets is related to constructors and calling methods. So a couple things to remember about that. So first of all, when you make a subclass constructor, you have to call super. If you don't call super explicitly, meaning that you like typed out super, Java will call super implicitly, meaning it does it for you. Okay, well, that's nice sometimes. But if there exists a constructor in your parent class that has any parameters at all, you have to call it, because once you declare a constructor in your parent class that has variables and constructors in the constructor header, you're basically telling Java that you no longer want its default constructor that it gives you for free. You have to use that constructor when you call super. So that's one thing that people often forget related to super and subclasses. And then another thing is when we have method calls, and I'm trying to think of where an example would be. So if somebody knows of one that you can see in your notes, let me know. But like where you have a couple different methods and one object calls a method and then it goes to another place and you have to know which method gets called. So what you want to remember for that is that the method that gets, whether or not you can call a method is based upon the type of reference. So like in the example I just gave here, a dot make noise is okay because a is an animal reference and all animals can make noise. A dot go outside or a dot use litter box, those are not okay because not all animals can use those methods. Let's say I had another method that was, existed somewhere and you called it. Every time you go to execute code, you always look in your class first. So even though this animal is a generic reference, it's a cat. So when I go to execute the code, it's going to behave like a cat. So like, think of it this way. You go into like an animal shelter. All animals are going to act the way they act, right? Like a cat's going to meow and a dog's going to bark. So it doesn't matter if you call it an animal, it's going to behave like the kind of animal that it is. So when you go to execute code, it's always going to look in its own class and use its own understanding of its methods first. And if that method doesn't exist in its class, then it will go up a level to its parent and then up a level further if it needs to, but it always checks its own code first. Does that help? Do you have any specific questions on polymorphism or inheritance I didn't answer?
That's about it. Thank you.
Cool. No, you're welcome. Are there any other questions? Anything at all? Sorry, I'm just checking the chat. Okay, let's see. Ruby, is that you with your hand up?
Yeah. Do you mind going over the Boolean, like the and or things where you have to like do those problems?
Yeah, for sure. Do you have a specific problem in mind or do you want me just to make one up?
You can just make one up if you can.
Okay.
Thank you.
You're welcome. All right. So, one thing with the Booleans is De Morgan's law. And with De Morgan's law, that's when you negate an and or an or. So that would be like if we had the not of A or B or the not of A and B. And so when we see something like this, the way you want to think about it is like you are distributing the not and then you're flipping the sign. So if it was an or, it becomes an and vice versa. So then this one become not A or not B. Now, where this can get a little bit tricky is when we start seeing like a bunch of these. So like, let's say we had not A or B. I'm like trying to think of a, okay, so let's say we had something like this. In this case, you're going to not, so then that would just or like cancel out. So it'd just be A and then and not B. So that's how you do something like that. I'm trying to think of does anyone have a specific like Boolean type problem that I could work through or that you have a question on?
What do you like do when the greater than or equal to signs get like involved in
Okay. So like let's say you were trying to negate, like let's say we were trying to negate x is greater than 5. So if you think about this, if we were on a number line and we had the 5 here, so greater than 5 is going to be everything that is like literally greater than 5 that does not include 5. So then if we were trying to figure out, okay, well, what's not included there? Well, first of all, that would include 5, and that would be everything in the other direction. So when you negate a less than or greater than, not only do you flip the inequality symbol, but you also either add or remove that equals to bar. So in this case, this would be, because it was greater than, now it becomes less than or equal to 5. And then vice versa, if we had like not x is, let's just say we had less than or equal to 3. In that case, this would just become greater than. All right, what else? Let's see, we've got 10 minutes left. Trying to think. All right, let me stop sharing here. Okay, so one of the documents that I had in the folder is excuse me, it's called like general review of topics. Where'd my mouse go? And it looks like this. So this was one of it was called 2024 Overview of Topics. So this is a good thing to look at just to kind of make sure that you're good to go on all of the foundational items. I don't know if there's anything in here that you see that you want to go over. Okay, let's talk real quick about the integer and double class, because especially on some of the older problems, they're used a little bit differently. In the like pre-COVID, I think you had to use like the new integer constructor, and you had to use the like dot int value and like those actual methods to access the values of the object. You don't have to do that anymore. Now they use something that is called like boxing and unboxing, where it does that for you. So like if you wanted to make an integer object, you can just say integer I equals 5, and that would make an object of the integer class with the value of 5. The reason why it's important to know how to work with the integer and double class is because array lists can only work with objects. So when you're working with your array lists of what look like int values, they're really the integer class. Let's see. All right, so array lists. There was a request to go over array lists. So let me go ahead and I'm going to switch back to my iPad. All right, so when you're working with your array list, so let's say I was making an array list of strings. My computer going to catch up with me. There we go. So if we look at how to make the array list, so first of all, that's something that we want to be comfortable with. You don't have to worry about declaring or importing the array list class. You just have to know how to work with it. So we say array list, and then in the angled brackets, we have to give the data type. So let's say this was an array, what am I doing? An array list of strings, and let's just say we called this names equals new array list. And you'll see a lot of the solutions include this additional thing here. You don't have to have that. It's just, it used to be required, now it's not. So let's say I wanted to add names to my array list. So I could say, for example, names dot add, and let's say I added Mike. So now my array list has Mike. And if I were to say names dot add, and let's say I said 0, comma Jim, what that's going to do is this is going to act like an insert. So it is going to go to position 0 and put Jim there, a new string Jim, and then anything that was in that place gets shifted over to the right. So now my array list will look like Jim Mike. And then if I were to say names dot add names dot get, yes, I can do that. Names dot get 0. What this is going to do is this is going to first get the value at position 0, and then it's going to add it to the end. So now this is going to add Jim again. And then let's say I wanted to replace something, like let's say I wanted to replace Mike with Michael. I could say names dot set position 1 with Michael. And then now this would no longer have Mike, it would now have Michael. Now, let's say I had this array list and somebody was like, if anybody is named Jim, we have to take them off the list. Well, removing elements is something that's often asked and tested and often misunderstood. So let me just say, we'll just pretend I have a little bit more elements in here. And let's say I had like Joe and I don't know, Susan, some really basic names here. All right, so let's say that's what I had. Well, if I wanted to go through my array list and remove every instance of Jim, we have to be careful because when you remove something, the whole list shifts over. And so the best way to remove elements is to actually start at the end of the array list. So you'd want to start with Susan and start here. And then you'd want to check her and see, okay, do I have to remove Susan? And then you would basically just keep on working previous. So I would essentially say, and I have to use a for loop, not a for each loop here because I'm going out of order and because I'm removing. That's another time you cannot use a for each loop. You can't use a for each loop when you're removing. So I would say for int I equals, I'd start the last index. So the last index is going to be names dot size and then -1. And then I have to keep going as long as I get to the beginning. So greater than or equal to 0 and then decrease. And then I would basically just say if names dot get I dot equals Jim. If that happens, then I'm going to do names dot remove I. So here's how this would work. The first time through, since I have, if I look at my indices, I have 0, 1, 2, 3, and 4. I check index 4. 4 is not Jim, so nothing happens. So now I go on and I'm on index 3. I check Joe. Joe is not Jim, so I keep on going. Now I get over here and I get to index 2. 2 is Jim. So I am going to remove Jim, which now Joe becomes index 2 and Susan becomes index 3. But I really don't care because I've already checked those. So now when I move on and I move up to index 1, I don't have to worry about anything getting skipped. Index 1 is not Jim, so now I go on to index 0. Index 0 is Jim, so I remove him, and then these renumber to be 0, 1, and 2. And so that is how you safely remove things. You want to start at the end. All right. We are almost out of time. Are there any other questions?
Where can I access the Google Drive with like all the materials?
For sure. You know the link that you clicked, like that document you clicked on to get to the link?
D stuff posted something or
Okay.
like on where like
Okay. Here, let me I will drop the link into the chat. Let's see. All right.
It's on the Schoology updates.
All right, so D-Stuff said it's in your Schoology updates. Also, I just put the link to the doc in the chat. And if you go to that doc, about halfway down, it's highlighted, it says folder of resources.
Thank you.
You're welcome. All right, well, thank you everybody for coming. I hope this was helpful. Good luck on your test tomorrow. We are almost there. If you are one of my students, I won't see you before your test, but you're welcome to pop in my room and say hi before you go. Those of you that are with D-Stuff, I know you see them in the morning unless you have a morning test, and that would make for a rough day. But anyway, good luck. And I will, once this video is done, like saving to the drive, I will I'll put it in that folder, and then I'll also link it on that YouTube channel, which is one of the lists that's in the slideshow.
I'll also add the link to the review folder Schoology for my classes.
Fantastic. All right, everybody. Good night. Good luck. Get a good night's sleep as much as you can.
Deuces.
Thank you.
You're welcome.
Thank you.
Thank you.